Let's look at 1.4.3.5 morning quiz review on limits. So number one says use the graph of the function f of x to answer each question. Use infinity, negative infinity, or does not exist where appropriate. So part A through C, we're just looking for the order pair to see if the order pair exists. F of 0, there's nowhere on 0 where the graph exists, so we say does not exist. Part B, f of 2 equals 0, so we're looking for the order pair. F of 2 is just going to be at the y value of 0. F of 3, we're looking for the order pair, so somewhere on 3, there's only one point that will exist. These are all holes on the graph, so the only point where the graph exists is at y value of 3. Okay, part D, we're looking for the one-sided limit as x approaches 0 from the left side of 0. So as we approach the left side of 0, so the 0 is basically the y-axis, and when the graph is approaching the y-axis from the left side of the graph, it's going to follow this branch, and this branch is never going to reach x equals 0. However, the y value, however, the graph is getting closer and closer towards it, and the y value is approaching negative infinity. So part E, limit as x approaches 0. So in order for a limit to exist, both branches of the graph, both sides of the graph has to approach the same y value from either side of 0. So from the left side of 0, so on the left side of the y-axis, the graph is approaching negative infinity. From the right side of the y-axis, the graph is approaching the y value of 2. So we see that these two graphs do not meet, and so therefore the limit does not exist. Limit as x approaches 3 from the right side of 3. So here's 3. From the right side of 3, we follow the right branch. The right branch, as we get closer towards 3, is leading us towards a y value of 2. Okay. X approaches 3. The limit, in order for a limit to exist, both side of x equals 3 has to approach the same y value. So as x approaches 3 from the left side of 3, the y value is approaching 1. From the right side of 3, the y value is approaching a different y value, 2. So the one-side limits do not agree, so therefore it does not exist. Limit as x approaches negative infinity. So as we follow the graph, following the left branch of the graph towards negative infinity, negative infinity is to the left of the graph. So as we follow the graph to the left, we see that the graph is leveling off at a y value of 1. So therefore y value is equal to 1. Another way to think of limit as this approaches infinity is think of it as horizontal asymptote. Does the horizontal asymptote exist? If it does, we can see that the graph is leveling off at a specific y value. Part B, step through continuity conditions to determine that the function is continuous at x equals 3. If not continuous, determine what type of discontinuity, whether it's removable or non-removable discontinuity. All right, so the three conditions for continuity is, does the order pair exist? So the x value in question is at 3. So f of 3, does the graph f of 3 exist? The f of 3 is equal to 3, so the graph does exist. Okay. Part B, the second condition is, does a limit exist? So a way to tell if a limit exists is we already determined that the limit is not going to exist, but using the language that we need to use for continuity condition, we're going to use one-side limit. So the limit as x approaches 3 from the left side of 3. So 3 with a negative here. This means one-side limit from the left side of 3 is equal to 1. So it's approaching 1. X approaches 3 from the right side of 3 is approaching a different y value, approaching 2. So therefore, we see the limit does not exist since the one-side limits do not agree, and therefore the second condition fails. And if the second condition fails, then we have a non-removable or jump discontinuity at x equals 3. Okay, number 2, we have to use the graph to answer each question. F of 0, we see the y value of 0 here. F of 2, so this is a graph of y equal 2 exists. That does not exist. We see that there's nowhere on the graph that exists. It's going to be a vertical asymptote. F of 3 is equal to 0. Y value of 0. So we see the graph. We're looking for a specific point. So at 3, the graph does exist. At x equals 3, y value is going to cross over at 0. As we approach -1 from the right side of -1, so from the right side of -1, we see the graph. As we approach this x value of -1, the graph is approaching infinity. Limit as x approaches 0, so limit as x approaches 0 is equal to 0. We see the graph connects through that point. So if it connects through a point, the limit and the order pair will agree with each other. Okay. Limit as x approaches 2 from the right side of 2. So here's 2 from the right side. We're looking at the right branch. It's approaching infinity. As we approach positive infinity, so as we follow the graph to the right of the graph, if we follow the right arrow off the graph, we see the graph is leveling off at y equals 1.